Alright guys, welcome to Lesson 2, Introduction to Probability. In this lesson, we'll use the rules of probability to compute probabilities of compound events in a uniform probability model, and we'll also understand that two events, A and B, are independent if the probability of A and B occurring together is the product of their probabilities, and use this characterization to determine if they are independent. So we'll be looking at these standards in Lessons 2 as well as in 3 and 4. How do you determine the probability of two or more independent events, and how do you determine the probability of two or more dependent events? We're going to be looking at some of that today. And as you can see, we've got some different probability vocabulary here. We have a probability experiment. It's the chance process or situation that leads to a well-defined results called outcomes. We have an outcome, which is the result of a single trial of a probability experiment. We have a sample space, which is the set of all possible outcomes of a probability experiment. We have an event, which is a set of outcomes of a probability experiment. We have the complement of an event, which we've seen previously is everything in the sample space except the original event in question. And then we have some other probabilities listed here. We have empirical probability, which is the ratio of the number of successful trials divided by the total number of trials. We have the theoretical probability, which is the number of successful possible outcomes divided by the number of total possible outcomes, assuming each outcome is equally likely. And then we also have subjective probability, which is a professional's estimate of the chance of an outcome occurring. Think weather probabilities and things like that. The law of large numbers suggests that as more and more trials of a probability experiment are attempted, the closer or more likely the empirical probability will match the theoretical probability. Let's look at a few probability situations here and determine whether they're empirical, theoretical, or subjective, and determine the probability in question. So what's the probability of rolling a standard six-sided number cube to a number with 4 letters in the spelling of that number? So again, what's the probability of rolling a standard six-sided number cube to a number with 4 letters in the spelling of that number? So what is that going to be? Well, that's going to be a theoretical probability, because we can calculate what that's going to be. Think about the numbers that you can roll with a six-sided number cube. You've got 1, you've got 2, you've got 3, we've got 4, 5, and then of course 6. And we want to roll with a number that has 4 letters, right, in the spelling of that number. Well, I think you only have 2 options there. We can figure out the theoretical probability of that. You've only got 4 and 5, if I'm not mistaken. 6, 2, and 1, they have 3 letters in their spelling. 3 has 5. So we've got 2 numbers out of 6, which also can be written as 1/3. As a decimal, that one's a pretty simple one. That's 0.3 repeating. And as a percent, we would write that as 33.3 repeating percent. You may see this rounded off to 33% or 0.33, but that's the theoretical probability there. Let's look at another situation. Janice attempted to shoot 34 free throws with a basketball. She made 19 of the free throws. Based on those results, what would you estimate the probability is to be that she makes the next free throw? Well, that's an empirical situation. We're taking a sample size, in this case 34 free throws, and we're looking at the previous results to make predictions about future events. So she's made 19 out of 34. Well, we would assume, all things being equal, she'll probably continue along that path unless this is a lot worse than she normally does or a lot better. So based upon what we've seen, that would be the empirical probability. Of course, to write that as a decimal, we would need to take 19 and divide that by 34. As you can see there, that's about 0.55. We'll go 3 decimal places, 0.559. So we'll go back to our page. So that's 0.559. And as a percent, we'll again round off to 1 decimal place on the percentage there. There we go. All right. A weather forecaster suggests there's a 40% chance of snow and ice on the next day. Well, that's a subjective assumption based upon, I'm sure, some probability model. As a fraction, 40% would be what? I guess 40 out of 100, which we could also simplify that to what? 1 out of 25, I guess, or excuse me. What am I talking about? Get rid of that there. Let's see if I can undo that. Don't even know where 1 out of 25 came from. That would be what, 4/10 or 2/5. Excuse me. There we go. And then as a decimal, that would be 0.4. Okay, if you wanted to write it as 40/100ths, you could do 0.40 if you wanted to. And then as a percentage, it was given to us in the problem, 40%. So 40 out of 100, that's 2/5, 0.40 or 40%. Or you could write 40.0% if you wanted to stay in line with our to the nearest tenth in the percentages. Let's see here. A person with 5 coins in their pocket, a dime, 2 pennies, and a quarter, and a nickel. If a person randomly picks 1 coin out of their pocket, what would be the probability that they get a penny? Well, that's theoretical, okay? I mean, this is a theoretical situation. We could figure out the probability to get a penny quite quickly. They have 5 coins. And all things being equal, let's take away the fact that the coins are different sizes and maybe it's easier to pick the quarter out than the dime because the quarter's larger or anything like that. But there are 2 pennies and there are 5 total coins. So what's the probability, if it's random, that it picks 1 coin out of their pocket? What's the probability that they get a penny? Well, it'd be 2/5, okay, or I'm just going to write 0.4 in this case, and then that's 40%. Okay, there's a 40% chance they pull out a penny from their pocket. Now, what's the complement of drawing a numbered card from a standard deck of shuffled cards? We got to know a couple things about cards. I want to highlight a few things. In cards, you have 4 suits, okay, hearts, diamonds, clubs, spades, and there are 13 cards in each suit. So we'll say 4 times 13. So there are 52 total cards in a deck of cards, excluding jokers. There are 4 suits, hearts, diamonds, clubs, spades, and we've got 13 cards that run from ace to king. All right, so what's the complement of drawing a numbered card? Well, in each suit, we have non-numbered cards. We want the complement, so the opposite of a numbered card. Well, the opposite of a numbered card would be the cards that are not numbered, right? So that would be ace, jack, queen, king. So you've got 4 that are not numbered, and then of course you have 9 that are numbered, the 2 through 10. So I've got 4 in each suit, and there are 4 suits. That would be 4 cards in each suit times the 4 suits. That's 16 total cards that are not numbered in a deck of cards. So what's the probability of pulling a non-numbered card? It would be 16 out of 52, which we could, of course, divide that out. Let's see, let's simplify this together. We'll divide both of those by 2. You get 8 out of 26. I think we could divide that by 2 again. That's 4 over 13. That's interesting. 4 out of every 13 cards, right? Because 4 cards in each suit are not numbered, and that would be the complement of drawing a numbered card. So let's go down. Let's look at a classic probability problem here. What's the probability of flipping a coin and having it land on tails? Write your answer in fraction form, decimal form, and as a percentage. Well, 1 out of 2. It's either tails or heads, right? As a decimal, we'll just go 1 decimal place, 0.5. And as a percent, 50%. You guys are probably used to saying, well, it's 50-50, right? There's a 50% chance of tails, 50% chance of flipping a heads. What's the probability of drawing an odd number card from a standard deck of shuffled cards? Well, think about what cards are odd numbered. And I'm going to take out the ace. I'm going to consider the ace not a numbered card, okay? So odd numbered cards. Well, I've got 3, 5, 7, 9, right? 3, 5, 7, 9. The 2, 4, 6, 8, and 10, those are even. I'm going to let the ace not be a numbered card. Thinking about the odd numbered cards, we have 4 per suit. And if you remember, there are 13 cards in each suit in a deck of cards. What's the probability of drawing an odd number card from a standard deck of shuffled cards? It's 4 out of 13, very similar to the question that we got earlier, because there would be 4 per suit. That'd be 16 out of 52, which is 4 over 13. Well, taking that back to, and you can see there I was looking at cards again, just making sure we're on the right page. So 4 divided by 13. So you've got about a 0.307 or 0.308, if we round that 7 up, 0.308 probability of drawing an odd numbered card from a standard deck of shuffled cards, all things being equal. A person has 20 rap songs, 15 R&B songs, 20 alternative songs, 12 pop songs, 5 country songs, and 18 hip-hop songs stored on an MP3 player. Total of 90 songs. If the person set the MP3 player to random shuffle, what's the probability of the first song being played being a country song? Well, how many country songs are there? 5. How many total songs are there? 90. So my probability is 5 divided by 90. So we're going to take that to our calculator. 5 divided by 90. And so there's about a 0.056 probability, 0.056, almost 6% probability of a country song popping up first if the MP3 player is set to random shuffle. All right. So we've got some more questions here. I'm going to let you work on these. I think you can handle them pretty quickly. These probability questions are not too bad. And if you have any questions, let me know. But I think this first video will get you through these. Send me an email or a remind message if you have any trouble with probability. And there's also a classwork uploaded to give you some more practice. Talk to you geometry students later.